Dear brothers and sisters, human civilization has come a long way, from fire, the wheel, electricity and engines to rockets and quantum computers. Yet one law, one force still quietly controls us: gravity, the same force that shaped galaxies, the same force that keeps planets balanced in their orbits, the same force that made life on Earth possible. Now imagine if India became the engineer of this universal force and invented systems to use this power in 100 new ways or more. Our channel mission Viksit India discusses innovative ideas in every episode to help India become a developed nation by 2047. Today, we explore a groundbreaking concept, the creation of gravity engineering as a formal discipline. We request you to stay with us till the end and share your thoughts in the comments. Gravity is the most familiar force in our lives, yet the least engineered. It governs galaxies, planets, time itself, but humanity has never learned to engineer gravity. What if gravity could be designed, controlled, or simulated? What if India became the first nation to treat gravity not just as physics but as engineering? What the world is doing today. Globally, gravity is studied only in theoretical physics, astrophysics, and experimental relativity. NASA, ESA, and China study gravity, but no country teaches gravity engineering as a discipline. Artificial gravity, gravitomagnetism, frame dragging, all remain fragmented research topics. Why this can be a historic opportunity. Every space station still struggles with bone loss, muscle degradation, and long-term human survival. Artificial gravity can solve this, including creation of gravity-based propulsion concepts, innovative energy systems, and new kinds of orbital habitats. This isn't science fiction, it's actually a science, just without an engineering framework yet. Why India can lead gravity engineering. India has, first, strong theoretical physicists, then cost-effective space missions and a growing space ecosystem. What India lacks is a national gravity engineering mission. If India creates the world's first gravity engineering curriculum, dedicated labs and long-term funding, India could actually define this field for the next century. Gravity shaped the universe. Now, it is time to shape gravity. If India takes the easy route and waits for others to turn gravity engineering into market-ready technologies, India may buy those products one day, but it will never become the nation that invented them. India can either wait for others or become the first nation to engineer the force of nature itself. India has a great scientific legacy. Thousands of years ago, on this very land, ideas arose that changed the direction of human civilization. India gave the world zero. Zero was not merely a symbol, it became the seed of algebra, calculus, computer science, AI, and space science. India also gave the decimal system, the backbone of every modern computation. Aryabhata proposed Earth's rotation nearly 1,000 years before Europe. The Kerala school wrote series resembling calculus centuries before Newton. Sushruta performed advanced surgeries around 600 BCE. Such foundational breakthroughs appear only once in a millennium, and very often they began in India. Today, India again stands at a historic crossroads to bring forth a new zero, a new foundational idea: gravity engineering. Gravity is still the greatest mystery. Newton taught us that gravity is a force. Einstein taught us that gravity is the curvature of spacetime. Yet the truth is this: we cannot increase gravity, we cannot decrease it, we cannot stop it. Gravity remains outside our engineering control. We live under its rules, design under its influence, but we have not yet engineered gravity itself. But remember, the first law of engineering is understanding the subject. Understanding precedes mastery. The deeper we understand a force, the more new sciences and technologies emerge around it. MOND, modified Newtonian dynamics, suggests that at extremely low accelerations, gravity behaves differently. This is not the complete physics of gravity, but it signals something profound. Gravity may not follow a single universal formula. It may operate differently across different regimes. If gravity does have these different regimes, then we could predict them, simulate them, and one day, engineer them. And here begins the imagination of gravity engineering. What exactly is gravity engineering? Gravity engineering is not about sci-fi style anti-gravity tricks. It means understanding the ultra-weak, relativistic and geometric behaviors of gravity and translating them into the language of engineering design. Just imagine for a moment designing zero-fuel, gravity-assisted spacecraft, building lunar bases that have artificial gravity sections, developing gravity gradient navigation systems as a sort of GPS alternative for deep space, creating sky-suspended megastructures and air-anchored sky bridges, even setting up airborne logistics hubs and floating solar farms. The goal here isn't to break gravity but to understand it so deeply that we can build a completely new infrastructure language for land, sky, and outer space, really expanding the living space for all living beings. In some parts of the world, nations have already started testing the limits of gravity. For instance, China has a simulated lunar zone in its territory for experimentation. It has created a land-based simulated lunar surface zone where astronauts experience nearly 1/6 gravity, similar to what they would feel on the moon. This is not virtual reality. It uses magnetic levitation, vacuum chambers and balancing systems to partially neutralize Earth's gravity. This is not true gravity control, but it shows the direction. The first practical step toward gravity manipulation has been taken by Chinese scientists. This is indeed vital to move ahead to find ways to engineer gravity. Secondly, decades before today's space ambitions, physicists demonstrated that gravity does not require a planet. In the 1970s, space physicist Gerard K. O'Neill showed that artificial gravity can be engineered through controlled rotation of large space structures, most notably through the O'Neill cylinder concept, which was rigorously examined in NASA-supported studies. Using only classical mechanics, these studies proved that Earth-like gravity, atmosphere, water cycles, agriculture and sunlight can exist inside non-planetary habitats, establishing gravity as an engineerable design parameter rather than a natural constraint. Thus, gravity engineering can be built upon this foundation by training engineers to design, control, and optimize gravitational environments for long-duration human habitation, orbital infrastructure, and future space civilizations, marking the transition from merely surviving gravity to intentionally designing it. Now imagine, if India, building upon such developments, creates a futuristic gravity isolation engine to modify the gravitational environment inside a spacecraft or space habitat. Interplanetary travel would become smooth, safe, and dramatically faster under the gravitational pull of the destination planet. No planet would be truly out of reach. Such a breakthrough would be a monumental achievement for India. What all could gravity engineering make possible? If gravity engineering succeeds in any practical form, it could transform the world as dramatically as zero once transformed mathematics. Imagine floating Indian megacities hovering above the layer of pollution, at the level of clouds, and almost free from earthquakes, floods, and storms. Gravity-based space propulsion-equipped spacecraft would no longer need massive fuel tanks, as it would use engineered gravity fields and interplanetary gravity tunnels to travel farther and faster with very little energy. It can also create low-gravity transport corridors above roads or up in the sky to create new transport routes, free from road transport routes to end traffic jam. Weightless construction can be possible. Construction materials weighing thousands of tons may feel as light as children's toys, making skyscrapers faster and safer to build than ever before. Gravity energy can be a new form of energy. Today, we depend on solar, wind, and nuclear power. One day, energy extraction techniques linked to spacetime curvature may open the door to an entirely new class of clean energy. Interplanetary gravity tunnels can be possible for creating gravity tubes that could reduce the travel time from Earth to the Moon to just a few hours, and to Mars to a matter of days. Revolution in medicine and bioengineering may be possible for creating artificial gravity chambers, fast recovery medical modules, and treatments that control cell growth using gravity, where microgravity and controlled gravity together open up new types of therapies. All of this may sound like science fiction today, but the real physical principles behind these possibilities already exist in physics. They only need a bold nation that chooses gravity engineering as its research mission. Why would this achievement be equal to the greatness of Zero? Zero didn't just solve a single mathematical problem. It was absolutely instrumental in the rebirth of mathematics, and it changed civilization forever. If India can actually show that gravitational effects can be increased or decreased, that inertia can be controlled, that stable anti-gravity zones can be created, and that space-time curvature can be engineered, then this would be India's greatest scientific achievement in history. Just like zero gave birth to the digital age, gravity engineering could give birth to an interplanetary humanity. Why India? And why now? India today holds three indispensable strengths: a massive young generation of scientists, ISRO's unmatched precision in deep space navigation, and the mathematical, AI, and quantum expertise of IIT ISRO and other institutions, along with the national vision of Viksit Bharat 2047 and a rising ecosystem of deep tech, physics, and space startups. Such an alignment of ancient wisdom and modern capability is exceedingly rare. If any nation can pioneer a new fundamental science, it is India. Now, we need a bold educational step, so we respectfully appeal to AICTE and the IIT Council to establish a new Bachelor and Master of Technology in Gravity Engineering and Spacetime Technologies. Students could learn things like general relativity, quantum gravity foundations, space-time architecture and design, AI for gravity modeling, and alternative gravity theories such as MOND, TVES, and emergent gravity. There would also be gravity sensors and ultra-low-force instrumentation, gravity gradient infrastructure engineering, space habitat gravity systems, and the role of gravitomagnetism. A crucial part of this curriculum will be gravitomagnetism, which is the magnetic-like component of gravity produced by rotating masses. Studying gravitomagnetism will enable students to understand frame dragging and spacetime vortices, model gravitational flows around rotating planets, design ultra-sensitive gravitomagnetic navigation systems, explore engineered rotational systems that can amplify weak gravity effects, and build AI models to detect gravitomagnetic signatures for deep space routing, earthquake prediction, and spacecraft stability. Gravitomagnetism will become a fundamental pillar of innovation to gravity engineering, just like electromagnetism is to electrical engineering. Its applied tracks could create things like sky-suspended buildings, gravity-assisted clean mobility, floating solar farms, earthquake risk mapping, deep space transport systems, air-floating data centers, low-gravity transport corridors, and mountain-to-mountain suspended highways. This curriculum would prepare India for the era of precision gravity engineering and position IITs and AICTE as global pioneers in this frontier field. From zero to gravity engineering, India must once again rise to give the world a new science. Mission Viksit India seeks to give India's research and development a new direction, a new speed, and a new courage. Today, we place the need for gravity engineering before AICTE and the IIT Council as a public appeal. Do you believe gravity engineering can become India's own scientific revolution for the world? Do you agree that India must urgently launch curriculum and research and development for gravity engineering as a national priority? If you agree, then send your email to the Union Ministry of Science and Technology and the All India Council of Technical Education, requesting them to take measures to start the gravity engineering curriculum as suggested in this video. You can share the link of this video as well. Share your thoughts, share this video, and subscribe for more future science and innovation content. Thank you for watching till the end. Jai Hind.